Hi, I'm Linda and I'm a chemist. In a single replacement reaction, your reactants are an element and a compound. They react to produce a new element and a new compound. Like elements will replace like elements. Atoms will replace other atoms with similar periodic trends. When you create new compounds, they must have a neutral charge, so you have to balance the compounds before you balance the whole equation. For example, magnesium and hydrogen chloride are the reactants. Magnesium will replace hydrogen to form magnesium chloride and leave hydrogen as the new element formed. A double replacement reaction is a type of reaction where the cations in two compounds switch places. In this case, we start with two different compounds, a compound plus another compound, and the products are two new compounds. Remember, when you predict the products, that you have to make sure the compounds have a neutral charge before you balance the whole equation. Double replacement reactions obey solubility rules when you are trying to predict the state of matter for your products. For example, potassium iodide and lead nitrate. In this case, iodide and nitrate are the ions, and potassium and lead are the cations. So they will replace each other to form the new compounds, potassium nitrate and lead iodide. Let's look at our products. We have one potassium atom, one polyatomic nitrate ion, one lead atom, and two iodide. We only have one iodide in the reactants, so we need to put a coefficient of 2 in front of the potassium iodide. Now we have two potassium reactants, but only one potassium product, so we need to balance the products and put a coefficient of 2 in front of the potassium nitrate. Now we have two potassium iodide plus one lead nitrate to yield two new compounds, potassium nitrate and lead iodide. A synthesis reaction occurs when atoms and/or compounds combine to make one new product. Let's look at an example. Magnesium is +2 and oxygen is -2, so the balanced chemical formula of magnesium oxide is MgO. Now we need to balance our reaction. We have one oxygen in the products, and we have two oxygens in the reactants. So we need to put a coefficient of 2 in front of the magnesium oxide in the products. Now we have two magnesiums and two oxygens in the products, but only one magnesium and two oxygens in the reactants. So we need to put a 2 in front of the magnesium. Now our reaction is balanced. We have two magnesiums and two oxygens in our reactants, and we have two magnesiums and two oxygens in our products.
A decomposition reaction is the opposite of a synthesis reaction. It is when one compound breaks down into two or more elements or compounds. Like mercury oxide decomposing to its elements, two mercury oxide molecules break down to two mercury atoms plus one O2 molecule.
A combustion reaction occurs when a carbon-based compound reacts with oxygen to produce water and carbon dioxide. In combustion reactions, our products are always carbon dioxide and water.
An example of a combustion reaction is propane and oxygen. Let's balance the equation. There are 3 carbons in our reactants and only 1 in our products, so we put a 3 in front of CO2. Then we look at the hydrogen. There are 8 in our reactants and only 2 in our products, so we put a 4 in front of water. We have 2 oxygens in our reactants, but 10 oxygens in our products, so we put a 5 in front of O2 to balance the whole equation. A propane molecule plus 5 O2 molecules forms 3 CO2 molecules plus 4 H2O molecules. So what have we learned? There are 5 types of chemical reactions: single replacement, double replacement, synthesis, decomposition, and combustion. There are 3 steps in writing chemical reactions: predict your products, balance the chemical formulas of your products, and balance your equation.